It's the question and answer period. So I'm going to invite all of the speakers to come back up and sit right here behind me. We have microphones. One is here and one is here. And we'll kind of go back and forth. So if you have any questions for the speakers, these are folks who are at the center of Mars exploration, engineering, research, and actually being there in space. We've got a question right there.
Speaking of cost, as you mentioned, it's really important probably to everyone in this room that we're spending money on NASA, and that's something that has been in the news in not so recent years and recent years. How can we ensure that you guys are getting what you need so that we can continue this and continue what you need?
Do you want to handle that one, Kay?
I'll make an attempt. Thank you for your question. And the question is, how do we as citizens and space fans, try to help support NASA's efforts? And I would say, first of all, follow what we're doing. We're getting really good about what we post on social media. Take a look at what we're doing. I'd like to thank everybody that showed up here tonight just by your presence. You're showing us that you're supporting what we're doing and you're interested. Share this message with your family and your friends. And hopefully we'll continue to get good support from Congress and from the federal government in general, as well as our international partners. So just out of quick curiosity, how many people have seen the International Space Station fly over? Ooh, pretty good. Could be more. So I have a challenge for you. Grab one of your neighbors, somebody who's never seen it sometime, and take them out and show them. And then take them back in the house, or even bring your, computer or your iPad or your phone out there and show them. There's folks on there right now going overhead as we're watching it, because I have found a lot of people seem to have a hard time differentiating between science fiction and reality. And if you're standing in your own neighborhood, your own backyard, you see the International Space Station go over, you go look up the websites, or you go look at even some of the NASA television and actually see the live feed of the people on board, it brings it home. These are humans, these are Americans, these are our international partners. They're up there doing this. We have these technologies we've already developed. We're actively developing the further technologies, as my two cohorts here have been telling you about, and to just continue to help us publicize the great things that we're achieving in space.
Joe, you want to add to that?
Yeah, the question of cost is a good point, and I want to make a point about cost. When we send a human crew to Mars, we don't leave the money on the surface of Mars. The money that we spend on this project goes to help people who work at the Johnson Space Center in Houston as salary, the Jet Propulsion Laboratory in Pasadena, Langley Research Center in Hampton. So the first thing is, we don't leave the money on Mars. We leave it on the Earth. It helps the economy on Earth. Now, the former chief scientist at NASA, Ellen Stofan, actually a graduate of the College of William and Mary, did a study or commissioned a study, and what she found out is for every dollar NASA uses in its budget, there's an amplification factor of 4.5 once that dollar gets in the economy. So there's a large amplification of the NASA budget. Furthermore, that NASA budget to support human exploration funds undergraduate and graduate students in about 250 colleges and universities in every state. Every state in the United States is contributing to the development of human exploration of Mars, building the launch vehicle, building Orion, doing the electronics, and so on. So this is being done by fellow Americans across the country. The total NASA budget is $17 billion a year, which is 0.5% of the gross national product. We're talking about a small amount of the total budget. And it has very significant amplification factor once it's in the economy.
So I'll add two things to that. Share the passion and share the rationale. And the rationale I like to use is that investing in space exploration is like an insurance policy for humanity. It doesn't pay immediate dividends, but long term, if nothing bad happens, you get the cash in on the annuities. And if something does happen, you're covered.
Can you guys talk a little bit about the path to what you do? I mean, in terms of high school studies, college studies, there's a whole network of people that support you all and are in your industry, and STEM is a big deal, and I think of it as a hot job. And can you talk a little bit about how someone would go into your field?
So I'm getting an example of a current path that's working very well for me and the folks I have. I run a series of student design competitions that look at architectures and robotics. I would say that 30% of the people we've hired in the last 10 years have come out of those programs. If you want to work for NASA, if you want to make the future a better place, get involved in those activities.
Certainly, the early astronauts were military test pilots, and we have a lot of astronauts with military backgrounds. But as you can see, as we evolve further and further into deeper space, human exploration of deeper space, we're going to value quite a wide range of expertise. Right now, I do encourage you to go online and read the biographies of those 12 astronauts that just started training back in August, and you'll be absolutely amazed. But, now we can find, of course, medical doctors and researchers. We've had geologists back when we were going to the moon. We had geologists. My first mission on STS-90, I flew with a veterinarian who became quite an experienced astronaut as well. So it's a wide range, and I think as we go further into space, especially heading towards Mars, we're probably going to need folks who have that strong math and science, STEM type of a background, but also a wide variety of experiences as well.
I think that that the United States of America is not producing the numbers of scientists and engineers that we should be. There are other countries that are outpacing us, and as I mentioned, science literacy, 25 in the world isn't anything to be proud of for the United States of America. We have more Nobel Prize winners than any other country. And one of the things that we think will happen in this human mission to Mars is that we excite the next generation of scientists and engineers who will be in elementary school. Once you're in college, once you're in high school, it's too late. My wife worked at NASA and did a study, and you really have to get these kids in elementary school. And we think that once we start this mission to Mars, and every night at 6 o'clock, you'll be able to watch the progress of the astronauts on this historic journey, you'll really excite the next generation of scientists and engineers. And we need more scientists, not to work for NASA, but for economic vitality, for national security, to increase the standard of living in this country. We have to produce more scientists and more engineers than we're doing right now. And I think that the space program, particularly a human mission to Mars, because it's so visible, will excite that generation.
There's a question right there.
I'm on the digital team here at the Community Idea Stations, and we've been taking questions via Facebook as well. So I have a question from Facebook. Will there be an orbital space station planned for Mars?
Okay, so there could be. What's interesting, if you look at a typical Mars mission, we bring an orbital space station with us each time we go to Mars, because that transport vehicle stays in orbit as the crew goes to the surface and back. So the answer to that is yes, in the context of a permanent orbital space station that stays in Mars when the crew is not on Mars. That's an option that's probably going to be down the road when we look at greater populations on the surface of Mars. Just like Earth now has a permanent space station, certainly in the future, someday Mars will have a permanent space station.
Would you describe some of the psychological testing, experiments, coaching, problems that you see and relate it not only to our normal psychology, but to the psychology of altered states? Thank you.
Sure. So I will admit to not being an expert on all of those, the research that goes on there, but I will say that there's quite a history of it. I remember even long before I became an astronaut, when I was studying some of the different space systems and such, that the Russians had quite a lot of experience on it before we did. They even had, I'm not even going to try to repeat them now because it's been a long time, but they actually had Russian terms for a couple of different types of situations that they could see, maybe with a crew, like what we might call a mutiny type of a thing, or that type of thing that might happen with a crew that becomes isolated or whatever. And so I think we learned a good bit from the Russians, and we continue to learn as we go, most especially more recently with the year-long study. So I will admit to not being an expert, but I will tell you there's probably a good bit of this that has been published and also is online, and look it up under the Human Research Program. Thank you for your question.
We have another write-in question. If there's no magnetic field around Mars to protect the surface from solar wind, how can you terraform? Won't the solar wind blow off the atmosphere before it can get established?
That's a very good question. And the creation of an artificial atmosphere on Mars is a function of the production versus the loss. We know the loss because there's no magnetic field to protect solar wind particles from blowing the atmosphere off. So we have to make the source stronger than the loss. In other words, the rate of production must exceed the rate of loss. And so that's how you can develop a stable atmosphere on Mars to make it more habitable for humans.
I'll point out one more thing, too, in the long-term vision of Mars and terraforming. Joel pointed out the abundance of water there. You didn't use the fact that, 1 meter, if you melted all the subsurface water that we think is there on Mars now, it would cover the surface a meter thick. So there's a lot of water on Mars. That's why it's a interesting site for future human habitation. Water equals air, oxygen, rocket fuel, everything equals life.
What other countries are in partnership with us in space, are most in partnership with us in space?
So our most visible international space station partners are Russia, of course, the European Space Agency. We have Japan as well, and I believe 13 international partners that we have been working with for many decades, or at least a couple decades now. So, and then at different times, we've had certainly researchers from all over the world, become involved in some of the science that can fly on board the International Space Station. So this is not a topic that is unique to the United States. We are, we certainly like to call ourselves the world leader, and I think all of us believe that in this space experience, but we also have great contributions from other countries as well.
Got a question right here.
How much would the trip to Mars cost in total, and how much would it put the United States in debt?
Well, the United States is already in debt. It wouldn't change it that much. percentage-wise. As I mentioned before, the trip to the surface of Mars is probably the most expensive part of it. The trip to orbit Mars, to get people in orbit around Mars, is a much more affordable step towards the surface. The NASA budget is certainly enough to cover that, but it would require reprioritization of what we're doing. We're doing a lot of things right now. If we do everything forever, we can't afford to do anything new. So the answer is it doesn't have to put us any more in debt, but we just need to do different things, and do them differently.
Just to add a little bit onto that, I don't have any actual numbers for you, but as Joel mentioned, this country needs more scientists and engineers. But also, as we go forward with this effort, we need the type of scientists, engineers, or even just designers who can look at the technology that we're developing to travel deeper into space and modify that and adapt it to applications that we can use right here on Earth, and commercial companies that can add that to the commerce of the United States. You can't put a dollar figure on that. So if we truly do go forward with this the way that we want to continue, to develop these technologies to send humans further into space, I guarantee you it will result in applications that will be commercially viable and will improve life here on Earth.
Another question over here.
Question for, thank you, Dr. Levine. So in your picture in which you were describing the generation of an atmosphere, you showed leafy plants. Was the use of photosynthetic bacteria considered, since they played a major role in the oxygenation of planet Earth? Would it work on Mars?
Okay, thank you. Frank Macrina is the Vice President of Research at VCU, a distinguished researcher, and an asker of very good questions.
I'm a microbiologist. So.
And a microbiologist, and he works for MCV and is Virginia's outstanding scientist, and has a best-selling book on scientific data analysis and how credible it is. Frank, those 4 charts were schematic, and the idea is that at some point, once we have a higher temperature, we want to seed Mars with living systems that can convert the atmosphere of Mars, which is 95% carbon dioxide, to oxygen. And photosynthetic systems like plants are one way to do it. That's schematic. And let me say that there is no plan within NASA to terraform Mars. And let me also say that once we find there is life on Mars, especially indigenous life to Mars, there will be no terraforming activity once we determine that there is an ecosystem on Mars. So I think that's just a schematic, and it's just in the planning stages. Nothing's being done.
We have a question over here.
Hi, this is for the space architect. I don't know if you've seen the movie or read the book by Andy Weir called The Martian. I want to know what he got right and what he got wrong.
All right, if you saw that little movie I saw, it said inspired by, one of the persons was Andy Weir. So everyone in my office read The Martian. We all went and saw the movie together. I saw it 3 times. What he got right was the need and the ability of the crew to adapt and overcome. That's the most important aspect of it, the spirit, the never give up, the engineering things, because he did that essentially in a vacuum. I know he's on Mars or some atmosphere, but he was cut off from Earth. And when I talk about the dormant modes where you have no access and the long delay, they got that right. Now, the whole thing with him using the semaphores and the bit language, I don't know. I would have just written something on a piece of paper, I think. But there were things with time and distance he didn't get right. I mean, we're not going to put a nuclear reactor in your rover and take it for a drive. Maybe you would, if you're really desperate. You're not going to tear the top off of your spacecraft to get it light. You know, we put a lot of effort into actually making those things function, and they're always on the hairy edge. So, and you're not going to Iron Man yourself across and do a hyperbolic rendezvous after you've blown the airlock on the front of your spaceship for return in a hyperbolic orbit. But it was cool, and we loved it.
I think one of the good things about the movie is it got a few 100 million people around the world talking about and thinking about Mars exploration. And I think Elon Musk is very good because he does the same thing. And I think Martian was a great public relations coup for Mars exploration.
Right here.
Yeah, I was just wondering about the development of nanotechnology and how it relates to the space program and deep space exploration.
So I'm not an expert there. However, we talked about rad-harding humans. Nanotechnology in the auspices of enhancing human biology could be a solution eventually to the radiation problem and maybe some other activities associated with people going to Mars. It's beyond my horizon in how I think of things and where it's going, but we must always be aware of enabling technologies and game-changing technologies like that and how we think and do things. Right now, I can't give you a single example where nanotechnology, other than maybe surface preparations to make it anti-static and keep dust off, that we're looking at. But there's huge potential there in materials. Materials, power density, and autonomy are going to be huge game chambers, not only here on Earth, but how we do Mars and go to space.
Right over here.
What does it feel like when you leave the Earth's atmosphere? What does it feel like not to have gravity?
Great question. I guess that's to me.
I've had dreams.
It's like your dreams. Actually, thank you for the question. I've been so fortunate to have the opportunity to fly into space twice. We train for it for years and years, and we fly in the simulators, and we have a really good idea what to expect, but when you actually do it, it's so much beyond that. It's really cool. The biggest thing that you experience is you're feeling the push of the rocket that's accelerating you to achieve a speed that you can actually get above the atmosphere. And we say microgravity because if there was no gravity, we would escape and just fly off into space. So it is the Earth's gravity that holds us in the low Earth orbit. But of course, we just feel like we're falling the whole time or floating. So it's you don't sense, as soon as you get to orbit, 8.5 minutes on Space Shuttle, at 8.5 minutes the main engine's cut off, and if we weren't strapped in, we'd all just float right out of our seats. As a matter of fact, that's when you find anything loose that somebody dropped, because suddenly it floats up. But at that point, after only 8.5 minutes and the main engine's cut off, suddenly you don't feel like you're moving at all. And when you look out the window, it just looks like the scene is moving past you, the Earth is moving past you, and we're just floating. So it's a great feeling, but the really amazing thing is how quickly the human brain adapts to that. And what we've also found anecdotally is folks who have flown in space more than once, is I know for myself personally, when I went the second time, within seconds my body said, I remember this. Watch this, and start, flipping around or whatever. But it is really neat how quickly the human body can adapt to that. But it is a pretty awesome feeling.
Thanks for that question.
This is a silly question, yet serious. Having the hand that each of you have in this wonderful science, especially Kay, where do you stand with roller coasters now? Are they completely underwhelming to you now?
No, I still love them. Oh my gosh, I'm a big roller coaster fan. As a matter of fact, I had some friends of mine within a couple of weeks of me going on my first space flight. Just back then in Houston, we still had Six Flags over Texas was right down there, and we rode everyone we possibly could, and it was a blast. Roller coasters, you actually experience the G-force in much different ways than you do flying up into space. At least in the space shuttle and the way we launch, we take the G-force kind of straight into your chest. It's a little bit different, and we're actually strapped in, very tightly to deal with the vibration we experience, at least on the space shuttle, under the solid rocket booster push that we get. But as soon as the solid rocket boosters are burnt out after a couple of minutes, the ride actually smooths out, and you just actually do feel the acceleration. But how do we stand on roller coasters? Personally, I still love them. I just I think they're great entertainment and great fun. And if there's anybody else out there that really likes roller coasters, you may be a candidate for flying in space.
I get sick of Busch Gardens, so. But I love it anyway.
Question over here.
Back onto Elon Musk and SpaceX, what would you say about the feasibility of his conceptual rocket and his timeline for going to Mars?
So his rocket's called the BFR, the Big Falcon rocket. Just get that clear. The SpaceX guys are very specific about that. SpaceX has demonstrated a proven track record of innovation. They took their, they did a reusable first stage, which we were hesitant to do, and they did it by putting a lot of margin in their system and using their commercial deliveries as a test case actually for landing a first stage. The current one where it's above the Falcon Heavy rocket, where he's talking about this major rocket that takes 100 people to the surface of Mars. The challenge I see with that is, what is the potential market for that? How is he going to turn a profit on that? It's a very large rocket. It has a single-purpose use. So technically, you could eventually get there. It's going to be more challenging than a series of smaller rockets. But he's proven everyone wrong before. So I wish him the best luck.
Justin Mayer, Naval Academy 03. So I'm all in on Mars exploration. I very much hope my children's generation, we see them there. But when we talk about a multi-planetary species, we do have a location on a relative doorstep. And so I'm curious, when we talk about getting to other locations, about the moon. And is it just that it doesn't have natural resources, it's just not cool enough? I understand you have to make choices, and I would love to see us in Mars. Or is it just we expect commercial, companies will be able to get there? But can you take a second to talk about potential colonization of the moon?
Okay, so the moon. I don't want to butt in. The moon is a much easier target than Mars. It's quicker to get to. It's easier to land on, and of course we've demonstrated because we've done it in the past. The difference between Mars and Moon, as we talked about before, is the abundance of available water. 5-10 years ago, we didn't think that was the case. We thought Mars was a dry desert, but we've been doing these subsurface radars and we've seen these large, glaciers is a bad term, but large, thick underground deposits of water that you can drill through a couple meters of regolith and get to. Water equals life. The moon, there is water in the cold, dark craters on the south and north poles. It's as cold as liquid oxygen in those craters. So getting into there, axing it, sublimating out, is a challenge. From a science perspective, I think Joel called the moon one time. What'd you call it? The Genesis. But what did you call it? Oh, you had this great term for the moon. What'd you call it? Anyway, he said it was a great place for geology and understanding the solar system. Here.
I think I would vote for Mars for the simple reason that the discovery of life outside the Earth is a profound discovery that's going to impact all of science, all of us that live on Earth. And no one thought we would find life on the moon, and we didn't. And I think that question, are we alone, which we've asked for thousands of years, we're at the point now to answer that question on Mars. Now what's happened in the last In the last 10 years, we've discovered 3,500 planets around other stars. They're called exoplanets. And NASA's Kepler Space Telescope can only look at nearby stars, and they can only look in a very small area of space, like the size of a full moon. And Kepler, in that small region, the size of a full moon, within 150 light years, we have discovered already 3,500 planets around nearby stars. We recently discovered the TRAPPIST system that has 7 planets around a star. And what we found with the Kepler instrument is that most stars have planets. In fact, there may be more planets than stars. So there are a lot of planets out there. Now let's talk about a galaxy, the Milky Way galaxy. Our galaxy is a collection of stars called the Milky Way. We think there are about 500 billion, with a B, 500 billion stars in the Milky Way. Milky Way is an average galaxy, and with the Hubble Space Telescope, on surveys it's done, we're talking about trillions and tens of trillions of galaxies in the universe. The James Webb Space Telescope, which NASA will launch in 2019, will be able to look back further in space than we ever have looked before, maybe to the point of when the universe formed 13.7 billion years ago. And the fact is, right now, we only know about life on one planet. That's planet Earth. And I think that we're at the point right now that we have the capabilities to look for life on Mars, which formed very similar to the way the Earth formed. And I think that the implications are so significant to find and study another form of life that I would vote for Mars over the moon for that reason alone. Now, there are secondary reasons about climate change and a whole bunch of other issues. But I think the question of life is very significant. And I don't think we're going to find life on the moon. I personally think we're going to find life on Mars, but it's going to take a human explorer to work the equipment and actually come up with an unambiguous answer to that test. So for that reason, I think I would vote for Mars, just for that reason. And, President Kennedy said we're going to the moon not because it's easy, but because it's hard. And we're going to Mars not because it's easy, it's hard. But I think there's so much to learn about our species and our role in the universe once we find other life on that planet, and what its impact will be on our knowledge of biochemistry, on disease treatment, and it's things we never thought of right now. Good question.
One last question from Gabrielle, and then we're going to wrap it up.
This question also comes from Facebook. How does living in space affect your dreams, or does living in space affect your dreams?
That's a great question. I wish I had more time living in space. Right now, the longest time we've had for any American in space is Scott Kelly, and so we'll be able to hear a little bit about that with the show tomorrow night. But for me personally, one of the things that's interesting is we talked about radiation, and we do get flashes, which is kind of interesting as radiation actually strikes your optic nerve and stuff. So sometimes, even with your eyes closed, sometimes you feel like somebody just flashed a bright flashlight in your face and your eyes were open. So on my first mission, I actually had a lot more of those than the second, and I don't remember any other differences in the dreams themselves, but I do remember a lot of times as I was falling asleep, not quite sure if it ever actually, the flashes actually woke me up, or maybe it was a sound that woke me up and then I had a flash or what. But it was luckily they had told us about this ahead of time. Otherwise, I'd have been a little concerned. But it is a very common phenomena to have that, and that can be a little strange. But I will say, when we come back to the surface of the Earth, a lot of times you do, maybe your dreams are that you're back in space and that you're just floating. And I remember, at least for the first couple of days after my first mission, waking up in the morning when the alarm would go off or something, and even before I opened my eyes, thinking I could just float up out of my bed. And then when I realized I couldn't, I was very disappointed.
Bummer. I think Joel wants to add to that.
You said you're going to wrap this up. Before we wrap up, I want to thank the station, WCVE, for this event. This took a lot of planning. This took a lot of planning and a lot of hard work, and I think we need more things like this to encourage science literacy, and I think this is a great way to begin. So thank you to the station and all the people, Debbie, and the whole team who put this thing together. Thank you.
Thanks, Joel.